Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Abdullah Gizi, Tikar Technical College, Head of Department of Electromechanical Engineering, Southern Technical University, South of Iraq, Basra. My topic, Improve Theories of Intelligent PLC Fuzzy Generator Parameter Control. Overall abstract about this my paper, we have designed the fuzzy PID proportional integral derivative PID controller by using the MATLAB and also the PLC for the set point, the voltage and the frequency. The proposed control arm to maintain the terminal voltage or the frequency on the continuous under any load operation condition, which attained the desired range of the regulation of generator government system. The main voltage control using the PLC implemented the AVR action. The existing algorithm, or propose this algorithm based on the controller include radial phase function neural network and real genetic algorithm implemented with the Sogeno fuzzy require the optimal tuning for the thematic factor operation of generator governor system. A newly developed controller combines real code genetic algorithm, radial based function neural network, and generator parameter with the fuzzy logical controller to determine the optimal PID control of the AVR. The keyword of this paper: generator governor, AVR, genetic neural fuzzy, radial based function, Sogeno fuzzy, fuzzy logical controller. Highlight for this paper: design the fuzzy PID controller by using the MATLAB and the PLC for the set point voltage frequency, and also propose the controller mounting terminal voltage frequency under the any load operation condition. Using the PLC to maintain terminal voltage to implement the AVR action, using the develop the genetic neural fuzzy PID controller that to transfer in PLC step 7.5.5 for implementing the AVR system and improve the system response. Administrating of the initial interaction between the generator terminal voltage and the excitation generator. The configuration, the hybrid control that between the generator parameter and the neural genetic fuzzy, and also frequency control by the controller. That means the completely control for the voltage and the frequency. Achieve the excellent voltage and the frequency control performance. Introduction. In this one now, it is well known that the main function of generator governor is the hybrid controller, where the terminal voltage and the frequency combined by the regulated the generator parameter voltage and the governor speed. PID inside the governor generator governor is responsible for the optimal control. Combining three coefficients include proportional integral derivative PID controller and also industrial control system. It is important to obtain the high quality performance in this condition. Our methodology for this paper, we are design the fuzzy PID controller depend on this algorithm by using the generator parameter tuning for the genetic algorithm to get the parameter PID parameter and enhancing by the radial based function neural network this parameter to get the adjusted the fuzzy rule KB, KD, KI depend on the generator parameter, and this generator parameter also the hybrid control system by combination the AVR genetic neural fuzzy PID controller designed by MATLAB and also combined with the industrial speed control for the governor. That is the combination the genetic neural fuzzy PID control designed by MATLAB and transfer to PLC by using the PLC PLC controller and the step 5.5 PLC, that's the control to transfer the generator BID from the MATLAB to PLC. To implement the experimental setup generator and the voltage sensor. The system is consists of the voltage sensor for the sensing the terminal voltage, and this combinational PLC card. This PLC controller, when the tuning by the BID controller to control the terminal voltage and by the sensing the terminal speed and also sensing the voltage, and also we design the fault system. This is the fault system designed to test the generator under three-phase ground fault, where with the circuit breaker that forgated the system to test the system under the service disturbance, and also when the internal combustion engine KS motor using for this setup as the prime mover for drive the generator to a suitable speed, and this speed is depend on the frequency the frequency of the system. And this KA internal combustion engine also control by sensing by using the KS92 controller for the speed control, for the adjusted the speed or adjusted the speed to with the set point, so that the controller and actuator system that is using for the changing the setup for the excitation system, where the generator excitation system is controlled by the BID controller. When they depend on the system, increase increase up and down the load, that may be needed to change the excitation current for the system, and that needed the high flux to generated by, and this changing and the controller is done by the AVR, that's giving me the terminal voltage constant under set point, and this system will be used to generate it and implement the system under tested, and also for the different characteristics for the BID novel controller, the genetic neural for the BID controller, and the speed controller for the governor. So the result will be good for this speed by using the implemented the generator parameter with the generator parameter with the genetic algorithm, and enhancing by radial bus function conjugated the 8 fuzzy states, including very low, for example, and low, medium low, medium and medium high, and high, and high low, and high medium and high. This is the set for the fuzzy set depend on the generator parameter of the kg and tau g, and varying between the kg generator parameter between 0.7 and 1 in step, 0.1 for each step, and tau g are varying from 1 to t in step 0.2 as shown in the table 2. This table will collect the results. When collected the results, these results are used by to implement it and design the fuzzy BID controller. This fuzzy BID controller used to implement it and transfer to from the MATLAB to PLC by using this step 5.5 PLC fuzzy set up for the generator experimental, and this fuzzy rule table formula for the KBKDK using the above approach. After the test of the system, we are using the three types of the AVR, AVR1 and AVR2 and AVR3. the AVR1 using implemented with the our controller, and AVR2 and 3 normally, so that to get the result, and compare the results and set up the system. We know that the small down the voltage when the three-phase ground fault at the terminal of the generator, small down and return to the steady state and the stability for the system. Compared with the another type of the AVR2 and AVR3, and that meaning they improve the stability and the transient response for the generator terminal voltage with the implemented with the novel controller. Also, the frequency response combined under the service disturbance, also AVR1 and AVR2 and AVR3. We know the AVR1 that implemented with the novel control is the good response and the small overshoot compared with the other type. Compared with the genetic neural phase BID control with the other another technique that in the previous paper. For example, MOMI fuzzy PID controller and case 1 when the beta 1 and beta 1.5, and also ENSAGI 2 FOBID. This is all paper that is the using in the different technique. We know that our technique that proposed by this paper is better than all, because they have the small overshoot and return to the steady state under the service disturbance. Compare the performance of the different evaluation algorithms. We know the difference also by numbers and the difference between the overshoot, time arising and time steady state and the steady state for the different technique compared with the proposed technique. Our technique is good. The optimal BID parameter for this case, the response of the system with the new fuzzy BID control is the high sensitive with the small very change 0.005, and also the proposed method achieves the good performance in the arising time, peak overshoot, and also steady state error. Also, novel controller improve the transient stability and minimize the swing in the terminal voltage between the up and down swing wave, and also they keep the system stability and reported for the different when they compared with the different technique previous paper. So we concluding that the developed algorithm provide high quality solutions and effective and offer the full control voltage or the frequency for the proposed system compared with the other existing techniques. Also the stability of the proposed neural fuzzy BID control administered through the experimental and the PLC controller and using the industrial KS92 controller was utilized. The improvement and also overall finally for this paper an excellent voltage and the frequency control performance is achieved, and also testing the proposed hybrid controller in practical AVR and the governance system on the synchronous generator for improve the transient stability. Thank you very much.